Okay, section 2.1, the addition property of equality. A lot of this stuff is going to be a review for you, so just a fair warning, it's going to be a review. An equation, a statement asserting that two algebraic expressions are equal. And a linear equation, okay, so it's important that you know what a linear equation is. Linear equation in one variable looks like this. We could have 4x plus 9 is equal to 0. Notice we have an equal sign and we have x to the first power. So x to the first power makes it linear and the equal sign makes it an equation. I'm going to move this out of the way, hopefully. Okay. These are all non-linear equations. Notice this one has an x squared, which makes it actually a quadratic. An x cubed is a cubic. 1 divided by x. X is to the first power. However, we're dividing by x, and therefore it makes it not a linear equation. This one is absolute value. Again, even though x is to the first power, this is not considered a linear equation. Solution is a number that makes the equation true. And okay, using the addition property, again, something that you should be familiar with. If I have x minus 12 is equal to negative 1, we're trying to get x by itself. I have to get rid of the negative 12. So the opposite of subtract 12 is add 12. You always do the opposite in order to solve. Solve is equal to negative 3 plus 12 is equal to 9. X equals 9 would be considered the solution. Works the same way with decimals. I would add 4.1. I'm not sure I can do this in my head. Hold on. Negative. The negative is bigger, so we know it's going to be negative. And when the signs are opposite, we subtract the numbers. So I'm getting 2.2. When we say the addition property of equality, actually subtraction can be defined by addition, actually. Subtraction means add the opposite. So when we say addition property, we also include in that subtracting. So let's say, for example, we have our x over here this time. Doesn't matter which side it's on. We just have to get it by itself. So we have an add 16. So we're going to subtract 16. And we have a negative 38. All right, notice I have z's on both sides. First thing, always first thing, get the variables on the same side. If they're on opposite sides, get the variable on the same side first. So we're going to subtract 11z, and we have negative 9 is equal to z. All right, again, we have two different variables, one on each side, and notice that this one is bigger. So what I'm going to do is I'm going to subtract whichever one will end up with a positive variable. Since this one is smaller, this is the one I'm going to subtract. Just as a reminder, as long as the denominator is the same and we subtract, we're going to end up subtracting the numerators and keeping the denominator the same. So 2 divided by 2, which is 1. So final answer, P is equal to 1. All right. Notice I've got a variable on both sides. I also have a number on both sides. Do the variable first. Variable first, variable first. So we're going to, okay, so notice I've got a negative 2x and a negative x. I could add x to both sides, but if I do that, I will end up negative 2 plus 1 is still negative. So what I'm going to do instead, I'm going to add 2x so that I end up with a positive x. It's always easier to work. That should be an 11. That should be a 10. Minus x is equal to 9. It's always plus. Sorry, plus. It's always easier to work with a positive than it is to equal, or it's always easier to work with a positive variable than a negative. Sorry about that. Subtract 10, and we get x is equal to -1. All right. So notice I have lots and lots and lots of variables, and I have lots and lots of constants. So what I'm going to do is I'm going to simplify the left side by combining like terms, simplify the right side by combining like terms. So I'm going to end up with a single variable and a constant, a single variable and a constant over here, and then 18r plus 4, and combine the r's, and I have 12r plus 4. And once I get to this point where I've simplified the left side, simplified the right side, that's when I'm going to get the variable on the same side. So subtract the 12, because 13 is bigger, so subtract the 12, and subtract 4, and we get r is equal to 0. A lot of students think 0 is not an acceptable answer. It actually is. 0 is a number. It's perfectly fine as an answer. 0 is fine as an answer. This one, you have to pay particular attention because you have to distribute. So we're going to distribute the 4, and we're going to distribute the 4. This one is the same as if there was a little -1 here. So we're going to distribute the -1, distribute the -1. So 4 times x, 4 times 1, -1 times 3x, -1 times 5. Don't forget to distribute that -1 to the 5. Students forget to distribute the -1 to the 5 all the time. So please don't forget. We're going to combine like terms, and our 4 and our -5. And then we're going to get our variable by itself by adding 1. We get x is equal to 2. And there you go.